In this example, we'll go ahead and graph another parabola in general or standard form. Our last video looked at a similar example, so if you want to go back and find that one, you can see another example. First up, I'm going to describe where the vertex of my parabola is. Well, the vertex will be made up of the h and k values, the numbers with x and y. Just be careful. Notice this time the x is in the back part of the equation. X always comes first in coordinates, so make sure you still put that in front, and remember to do the opposite of these values. So the vertex should be at -4, -1 for our parabola. So I'll go ahead and plot that point. 1, 2, 3, 4, down 1. So my vertex is going to be right there. You may want to label these points as you go so you remember what's what. There's the vertex. Okay. Next thing I'll do before I find these values down here, I want to go back and kind of take a look at what direction this parabola is going to be facing, whether it's up, down, left, or right. And the other thing I'll do too is let's go ahead and pull the 4 out of this number in front of the x parentheses. Divide that value by 4. And if the problem is nice, they'll give you something that works out nice and neat like that. But always divide out of 4. That was part of our general or standard form of a parabola. That 3 then is going to represent the p-value, or the distance to the focus, the distance between the vertex and focus. So here's what I'm noticing to determine whether this parabola opens up, down, left, or right. I'm noticing that it's a y-squared parabola, which is going to tell me this is either opening to the left or opening to the right. Since the p-value is positive, that means this parabola is going to be opening up towards the right. So it's going to look something like this. Okay. The reason that helps me then is I know which direction my focus is going to go in. My parabola needs to wrap around the focus, and since it opens up to the right, my focus must be somewhere this way to the right of my vertex. So that p-value of 3 tells me it's a distance of 3 spaces. So if I count that out, I should end up right about there for my focus. So I'll go ahead and plot that point, and if you want to label it focus, that could probably be a great idea, because we're going to start to have a lot of points here in a minute. The coordinates of that focus are -1, -1. Alright, next up I'm going to find the directrix. That's the equation that the parabola sort of bends away from. It wants to get away from that. So, and it's symmetric there's symmetry between the vertex and the focus, and the vertex and the directrix. So since we counted 3 spaces right there to get to the focus, we're going to count -3 spaces, or 3 spaces backwards to get to the directrix. So if I count backwards 3 spaces, 1, 2, 3, that puts me right here, and that's going to be a line. So not just a point, but a line. So get a vertical line right there. Vertical lines always have an equation of x equals, and if I count that out, it appears to be x equals -7 for that location. Next up, I'll do the axis of symmetry. Since we know we have a sideways opening parabola this time, my axis of symmetry is horizontal. It's going to go right through the vertex, right through the focus. Horizontal lines are always y equals, so y equals -1. So lastly, I want to find everyone's favorite thing, the endpoints of the Latus rectum. Well, to do this, I'm going to want to go back to my equation, and that original number in front, the number that had already been multiplied by 4, that 3 times 4 value, that 12, represents the length of the Latus rectum, specifically the absolute value of that number. So the length of the Latus rectum is going to be 12, but I want to make sure that's symmetric, that's evenly split on either side of the focus. So go ahead and divide that value by 2, and we get 6. And what that's going to tell me is from the focus, which was that value right there, I'm going to count 6 spaces up and down to find the endpoints of the Latus rectum. So 1, 2, 3, 4, 5, 6 spaces up. Now this will be a point on the parabola, so my parabola will go through that point and the vertex. It does not go through the focus. Then we'll count down 6, 1, 2, 3, 4, 5, 6, so right there. And so the total length between those 2 green dots I just put down is a length of 12 to represent the Latus rectum. And so my parabola will go through the vertex, through that point, and then also down here. And I'll go ahead and draw in the dashed line to represent the Latus rectum, the 2 points that connect, those 2 points that go through the focus right there. And so there's, actually, let's do one last thing before I wrap this up. Let's actually write down those coordinates of the Latus rectum. So if I count those coordinates out, I end up with -1 and 5 was one of the coordinates, and then -1 and -7. Alright, I guess as the last thing I'll do is let's label a few things on here. Let's see, that was the vertex, so I have that labeled. The focus was that point right there that the parabola wraps around. This dashed green line represents the Latus rectum, so I'll abbreviate that. The red dashed line, so much to label on these. The red dashed line represents the axis of symmetry that goes down the middle of the parabola, and then finally the directrix over here, that dashed vertical line this time that the parabola tries to bend away from.